Each of these challenge problems has something uniquely challenging about it. Okay, let's look at this one. Remember, the process is still the same. I'm still going to ask myself, is there a GCF? In this case, there is. What's a number that multiplies to 6, 3, and 84? Well, 3 is the smallest number here. 3 does multiply to 6, and it does multiply to 84, so I'm going to take that out. There's also, look, there's 2 extra x's on each of these, so my GCF is 3x squared. I'm going to factor that out. This becomes 2x squared plus 1x. And then let's see, 3 times what is 84? I'm going to just do some little long division here. 28. Okay, so this is negative 28. Okay, and that still equals 0. And then I'm still factoring. I need this times this to equal this, and this times this to equal this. So this is going to be 2x times x. And then my 2 numbers, so this is going to be a positive and negative. I'm just going to write lightly. I might need to move these around. But 2 numbers that multiply to 28 are 4 and 7. It could be 2 and 14. Could be 1 and 28. Let's start with the 4 and the 7. Right away, I think like, okay, I'm trying to make it add to 1. So how can I arrange 4 and 7 to add to 1? Well, let's do the 2 times 4. That'll get me 8. And then 7 times 1, that'll get me 7. So perfect. In this case, though, however, it's, look, this is negative 8 plus 7. That would be negative 1. So let's go ahead and switch my signs. I want it to be like this, positive 8 minus 7. Perfect, that would equal 1. Okay, so my factoring is done. And now I notice I have 3 parts that equal 0. So it's going to be either 3x squared equals 0, or 2x minus 7 equals 0, or x plus 4 equals 0. So what are my solutions here? Here, look, like I could divide by 3, but you can just kind of look at this and see, okay, what would x have to be in order for all of this to equal 0? It would just have to be 0, right? This would be 0 squared is 0 times 3. Okay, so here x equals 0. Here I would add 7 on both sides, and then divide by 2. I would get x equals 3.5. And then here I would be subtracting 4 on both sides and get negative 4. So my 3 solutions are negative 4, 0, and 3.5. I just left you a little bit tight on space for that one. Okay, this one has a very specific challenge, and after that, it's not too challenging. The challenge is this, look, this is not equal to 0. But the whole thing that I need when I'm solving by factoring is that it's equal to 0, because otherwise I can't make, I can't say, well, everything's multiplies to 0, one of them must be 0. So watch what I'm going to do first. I'm just going to make this equal to 0. Look, this is negative 20. I'm just going to add 20 to both sides. Now it equals 0. And now this is a pretty straightforward problem where I need 2 numbers that multiply to 30 and add to 11. Those numbers are 6 and 5. And I would end up with my 2 solutions of negative 6 and negative 5. Okay, this one is tricky just because it doesn't look like what you're used to, but we're just going to do the same process, which is we're going to ask ourselves, is there a GCF? And I say, well, 6 multiplies to both 6 and 6, and there's also an x here. So this becomes this, and then I can factor this part. And this one is just kind of tricky because it just sort of looks different than what we're used to. But in fact, it ends up being kind of like this, where there's 3 factors. Okay, and either this equals 0, or this equals 0, or this equals 0. And my 3 answers end up being, look, negative 1, 0, and 1.